Dear students, firstly, I will introduce myself as a Chobe, working as assistant professor in electrical engineering department at Ascending College of Engineering, Yola. So up till now, this is going to be the just way of saying that high voltage engineering. We are saying this one. So firstly, we will take the review of what up till now what we have studied. So when we take the review, we will start from the first one is the what are the good properties of the good insulating material. We have seen the good properties of the insulating material. So now then later on we will go for the ionization. What is the ionization? What is different ionization, photoionization, ionization due to collision, ionization due to collision, then due to impact, primary ionization, secondary ionization. What is the difference between the primary ionization and the secondary ionization? Then later on, we are also seeing what is electrical discharge, right? Then later on, we are also seeing the two theories, important theories in case of breakdown in gases. That is the Townsend theory and the Steamer's theory. So the question arises when we should apply Townsend theory, when we should apply the Steamer's theory. So always remember one thing that when we are studying the Paschen law, what is the Paschen law? Give the relationship. Paschen law gives the relationship between P and T, gas pressure and the distance between the electrons. So the same case when we are studying this, in this case, Townsend theory is applied only when PD is less than 1000. It must be the uniform theory, then the Townsend theory. But we also in the last lecture we are seeing the drawbacks of the Townsend theory. It means Townsend theory only contains the ionization. It does not take the gas pressure and the gap distance. So for this purposes, this is the drawback. We are going again for the next one, that is the Steamer's theory. Steamer's theory is applied when PD is greater than 1000, it means for the non-uniform pressure. Then later on we have seen, after now we are seeing what is the breakdown in vacuum. Breakdown in vacuum. Just we are seeing that we have seen, last lecture we have seen the two methods. And this is the last method of the breakdown in the vacuum. And that is the last portion of your topic, breakdown in that. So up till now, what we have seen is what doing the vacuum? Question arises. What doing the vacuum? When can you say that there is a vacuum? Vacuum needs to maintain the pressure much below the atmospheric pressure that is called as the vacuum pressure. Remember? So in the case of vacuum pressure, what are different breakdown of vacuum? There are three methods are available. I have told in the last lecture. Three methods. First one, particle exchange mechanism, field emission theory, and the Clump theory. So up till now, what we have seen in the last lecture, particle exchange mechanism and field emission theory. Now the last one that is remaining for this the breakdown in a vacuum is the Clump mechanism. Why it is called as Clump? Clump is nothing but the loosely attached particles. What is by clump? CLUMP, clump means nothing but the loosely attached particles. These particles are causing the ionization in the vacuum, so it is called as the clump mechanism. So what happened? See here. Basically, this theory has been developed on the following assumption. A loosely bound particle, see, clump, exists on one of the electrode surfaces. On the application of the high voltage, this particle gets charged. When it is going to be charged, it is detached from the mother electrode. It may be anode, mother electrode, maybe cathode, and is accelerated across the gap. Vacuum breakdown occurs due to discharge in the vapor or the gas released by the impact of the particle at target electron. What is target electron? If it is going to be emitted from the cathode, what is the target electron? That is going to be anode. If it is emitted from the anode, what is the target electron? That is going to be the cathode. So this is a simple. Remember one thing. This theory happens only due to loosely bound particles. That means there are some particles on the electrodes that are very loosely bound. This causes the breakdown in the vacuum. So this is called as the clump or the loosely bound particle breakdown. So we'll see here. See here the diagram. Here the clump is formed. First you see a diagram. This is the cathode, this is the anode. This is the clump between loosely attached particles. These are across this cathode, these are nothing but the electrons. Right? The clump is loosely attached to the surface, right? Now, second one, these particles, when the high voltage is applied, these particles are going to detach from or removed from this, and you see here the second case. These are removed in this case. Where they are going to be attracted? They are going attracted to the anode. Clump is detached from the cathode surface, it is accelerated across the cathode. When they are accelerated, high voltage is given, they will accelerate. Now the next one is the impact of the clump on the anode and gives out cloud metal vapor. It means what the metal that the anode is formed of that metal, the vapor cloud is going to be formed, and this is going to be causing the breakdown in the clump theory mechanism. The first one who discovered this, that is going to be the Clump, was the first to propose this theory. He initially assumed that breakdown will occur when the energy per unit area W delivered to the target electron by a clump exceeds the value C. What he is saying? When the energy per unit area W delivered to target will exceed the target electrode and actual value C dash a constant characteristics of a given pair of the electrons. Because more energy is required. What is the characteristics of a given electrode that is going to be given by C dash? When V is going to be W is going to be greater than C dash, then and only then clump mechanism is occurring. Remember, when W dash is more or exceed C dash, then and only then clump mechanism in the occurring in the case of vacuum. The quantity W is product of the gap voltage and the charge intensity on the clump. What is W? W is nothing but the product of the gap voltage and the charge density on the clump. The latter is proportional to electrical field A. Proportional to electrical field at the electrode of the original. The criteria for the vacuum breakdown therefore is given that V into E is equal to C dash. It means V, the gap voltage into the electrical field should be equal to the constant C dash, which is nothing but the characteristics of a given pair of the electrons. So this is simple theory for the clump mechanism or the clump theory. See here this one. Cathode, vapor cloud, electron stream. Here vapor cloud is formed across the, because why vapor cloud is going to form? Because here is the loosely attached particles which are removed. Where the electron stream is going to form, they are attracted to the node. Breakdown in the cathodes, breakdown in the vacuum caused by heating of the micro projection on the cathode. Where is the projection of that one? That is on the cathode. So thank you. Just I am going to tell you that we have just completed your first unit, that is the breakdown in the gases. In the next lecture, we will go for the second unit, that is going to be the breakdown in liquid and solid dynamics. I have already told, when we are studying the high voltage engineering, breakdown is very important. Because from that one, we all know that what is the breakdown voltage of that one, breakdown strength of that gas or that liquid or that solid. So this is going to be important. So thank you everyone.